Hey everybody, Casey Muratori here. This is our very, very last Kickstarter promotional video. Our Kickstarter is winding down right now. It's for our graphic novel series, Meow the Infinite. We were doing a print run for book 2, and we'd love to send you book 1 or book 2. It's a great graphic novel series, and we'd really, really like to get you reading it. So please check it out if you get a chance. It's just about over. And so is this promotional series, and this is the very last video. Before I go into it, I would just like to say thanks everyone who tuned in to watch these. It was actually a lot of fun. It was a lot of effort, but a lot of fun. And thanks to everyone who actually backed our Kickstarter. We really appreciate it. We love doing graphic novels. It's one of the things we do here at Molly Rocket. But it don't mean anything if we can't actually send them to people to read. So we really appreciate it. Thanks everyone who went and backed and made the Kickstarter a success. So we really appreciate it. And for any of you who haven't, it's still up for a few more days, so please check it out. This is the very last video. It's the question and answer session for the lecture that was Where Bad Code Comes From, which hopefully you've already watched. If you haven't, some of these answers might not make as much sense, although some of them are kind of generally applicable, I would suppose. So please go watch that one. The link's in the description below if you haven't already. This is the Q&A for it, where I try to give some additional perspective to people who have questions about some things, about, like how what I said in the lecture might apply or not apply to the sorts of things that they do. So I hope you enjoy that, and I'll be back at the end to say a final goodbye for the Kickstarter promotion series. The latter. So I would say that there's really nothing wrong with rules of thumb, and you will hear me say them sometimes. I'll be like, error conditions should always go on the handle or something like that, right? That's a rule of thumb. The important thing is not to not have rules of thumb, because I think rules of thumbs are actually fine. The important thing is just to recognize that whenever we teach a rule of thumb, we have to be specific about the fact that it is not the goal. Right? So the goal of developing a cryptographic, like a cryptographic hash function, the goal is not to obey the strict avalanche criteria or something like that, right? We just, here's like the reason why we decided that was a good idea, and it makes good sound sense. Something like the strict avalanche criteria is like way better like thing than, anything in solid, certainly, but you know what I'm saying. The important thing for the programmer to understand is what were the actual things we were trying to achieve? And then the rule of thumb always goes on top of that, right? Because otherwise what happens is each generation, it's almost like a bad game of telephone, right? The early cryptographers who created those rule of thumbs knew that they were rules of thumb for accomplishing a certain set of actual things they were trying to measure. Now the rules of thumb become the thing you're trying to accomplish, and the next round has like rules of thumb built on like the rules of thumb. Right? And it keeps degrading. And that's how you get to something like, hey, what we're going to teach, we're teaching solid, right? It's like, no, like you can't teach solid. Solid is just some ideas not very well validated about how to accomplish something. We need to teach the thing we're actually trying to accomplish. So I would say like, yeah, I don't have any problem with rules of thumb because in general, they help communicate things you've found that help to minimize those actual things we care about. So as long as we're upfront about it, I think it's great, So I would say it's a I don't know if double-edged sword is the right word, but so here's what I would say. When my dad was actually a programmer, when he learned to program right, it was on punch cards, like kind of what you were alluding to, right? What that meant is that like even just a syntax error of some kind, like something that the punch card machine would like error on, meant a lost day. Because you were going to submit those punch cards and you were going to get back, instead of a run of your program, you were going to get back it was an error, right? While that does produce a certain discipline, we have to ask ourselves, do we care about that discipline? Do I care about building up a thing in your brain that's really careful about syntax errors? I don't think I do, right? So while it's true that some constraints help to educate people, some constraints may just be educating people's part of their brain that we didn't really need to educate. Like we didn't need that thing. So I would be careful about, saying that if everyone went back and programmed punch cards for a year, they would be better. I don't know that they really would be. What I do think is true about those things is if you look at today's programming, it may not be as far away from that as you think. I use the example of TensorFlow. It literally takes like hours to build that program. It's not that much different than the way my dad used to have to program. If he wanted to get a compilation result out of a full build of his thing, here are the punch cards. TensorFlow is the same way. Like, you're going to get lunch and you come back before it builds, right? So I guess what I would say is, I don't think constrained programming is all that valuable unless you choose the constraints very carefully. And furthermore, I would say that the lack of some of those constraints is actually very valuable. Fast turnaround times lead to much more exploration in a much shorter period of time. You will find better solutions, right? And so in many ways, I would say we don't want to fetishize anything that used to be an impediment, because if we start thinking we need to have that particular impediment and really it wasn't that valuable, we're just hurting ourselves. And I think that would be the case with like long compile times. I don't know if that answered the question, but that's the way I think about it. So I think that is everything you just said is exactly what I think as well, or rather, it totally comports with my observations about things. And if I can use a metaphor from the presentation, what I would say is, to me, I really do think about things as exploration. And so I think about it as like, look, there's a certain amount of things you can do to plan for an exploration, like take enough food and you need a big boat or something, or this many people. There's some limited things you can do. But at the end of the day, if you do not fundamentally know the exact layout and region that you're going in, the temptation to go, we're going to go up through here, and then we're going to cross this mountain, and we're going to go through this, right? If you've never done any of that stuff, it's all BS. It's just a pipe dream, right? It's like you're imagining that the world that you will encounter looks like something that when you get there, it will not look like that, right? Even if you've been there before, sometimes they look like that. There's an avalanche now, right? The past has changed. You can't go through there, right? There's a war broken out among the people that live there. That part is too treacherous, right? Whatever. And so to just I mean, obviously you didn't have it very long to explain the complete thing that you were talking about, but if I could extrapolate from it, someone who comes from an assembly language background knows that the way that you get that code to be good is by spending the majority of your time tinkering with the code. You create different versions of it, you time them against something, you see how that code performs in practice. That is true, I think, more of regular code than anyone admits. The tinkering, refining, trying, and actually testing against the real thing is way more important than any planning. And so I think that if you could do something systemically to improve your chances of success there, it's to just, as much as possible, try to do your planning after the fact. Let people try some things, experiment with some things, try a little bit of whatever you're going to do, and then make a decision about where to go. It's like, go to the place you're exploring first. Send out some scouts. Now make a decision about where we're going to go. Don't plan before you have information that you need for planning. And so, for me, I really just think there's way too much process that happens before you have the information that the process could actually be useful for doing. And that's why you end up in these situations where a ton of code has been generated only to find out that you still haven't gotten anywhere. And it's weird, but you find this happen a lot. It's like people write this entire thing and they're like, okay, we finished. The graph system is set up and you just plug these things together and it will do it and it'll solve the problem. And then you're like, okay, so have we solved the problem? It's like, no. But when we plug these things together, it will sort of solve the problem. You're like, okay, let's plug them together. You plug it together, it runs like crap, right? It's terrible. No one can debug it. It's like slow, and you're like, oh my God, what have we done? This happens over and over, and I think fundamentally, yeah, it's just because that upfront thing that doesn't focus on actually getting the thing to work, it's all almost wasted time, or wasted's even generous. It's counterproductive. It leads you to do things that you really shouldn't have done. So I don't know if that's really responsive to your question, but at least from what I heard from what you said, I'm like 100% with you on that feeling, right? That feeling that there's something bad here. So I don't want to get you into trouble by appealing to your inner assembly language programmer and then having everyone on the team not want that to happen or something, but I'm just going to say what my opinion is on that. In my opinion, upfront design is always bad. Not sometimes bad, always bad. And the reason for that is because upfront design is basically like an incorrect map of where you're going. If you knew what the design was enough to design it up front, you already have the code. Because that implies that you've already done something so exactly like the thing that you're doing that there's no mystery, right? And not only have you done something just like what you've been doing, but the knowledge in your brain, which is very imperfect, even the very best coders do not have every last detail of everything they wrote on a project completely in their brain for next time. It's a bit lossy, too. It's like the explorer drawing the map when they get back home. Well, you know. So, to me, it's always a bad idea to do that upfront design, and I would never structure a systemic process that way. What I would do is I would say, all right, what we're going to talk about when we talk about upfront stuff is who is responsible for the scouting. Right? We know that there's this thing we need to design, and we haven't designed it yet. And we furthermore know that there's multiple people working on it, so we can't just have you just go like find, the promised land and then be there and be happy, because all the rest of us are, well, now we're sad that we didn't participate, but I mean, ostensibly you will encounter like things that you could not pass by yourself is the analogy, right? Like you will encounter things that was too much work. Too difficult. This cliff can't be scaled with less than 3 people, right? That's just how it goes. We need to work together. So what I would say is the process should be about going, okay, we know that, at least in my worldview, the design of code comes out of seeing what the way is to efficiently do something you were trying to do. The design comes out of the efficient version. And the reason that we know that ahead of time is because you cannot performance analyze a document. The document cannot be validated against anything. So we know that if we actually want this thing to be good and not merely just something that conforms to a document for no apparent reason, we have to actually produce something that we can test, right? And in my world, this can be like a very specific thing. It's like, look, we know we need to compute lighting on this scene. We know we need to trace this many rays through this scene. So what's our fundamental ray throughput going to be? What's the highest ray throughput we can get, right? These are questions that we answer first. We never talk about the design of a program until we first answer what's the most efficient way that anyone on the team found who's any good at that sort of thing. What's the most efficient way they found to trace rays on the target hardware, right? To compute that thing. And then we get together and say, all right, it turns out we bundle them together in 8 wide bundles. I load them in using AVX2. We do these kinds of things. The triangles are preprocessed this way. That was fastest. Now, how do we then take the next step forwards? Somebody goes, maybe it was the person who found that, and like cleans that code up, gets it into a library, puts an API on top of it that we think is something we're going to use, right? We now know how it has to be called. The next set of scouts go out and do their thing. Like, what's the next piece we don't know, right? Designs that happen first produce bad software because they've never had that done. So the design had something in it, and you'll go implement that thing, and then it turns out it was wrong. It's not a fast way to do that thing. And now you're stuck because everyone went off and implemented things based on that design, and it may have locked you into an architecture that just can't change, right? So to me, you always do the other way if you can. You always do it the other way around. Explore first. Whoever finds the solution to that thing, then we get together. Then we talk about what design is that conforms to that, and we move forwards, right? To me, that's how you do it. Thank you. It's a great question. I mean, if that was the case, if I really thought that I'm like, I don't know if I'm going to actually be raycasting triangles or something, then usually what I would say is you have to do a different type of exploration up front. If you're so in the weeds about what it is you're actually building that you don't even know what the components of what you're building are, then that's the first scouting you have to do. Like, okay, we got to experiment with algorithms here. Like, are we going to trace rays? Like, let's do some lighting, let's do some lighting experimentation first. Let's put a couple people on that and figure out, do we even need this thing, right? And raycasting triangles is maybe not the best example because it is the kind of thing that we can maybe easily cabin off. So another decision we could make is like, well, we know there's going to be some kind of raycast here, and the only real mystery is like how the triangles will be stored. Maybe we can guarantee in our pipeline that we don't care. So we can kind of cabin that part off, right? But more important are things like, okay, we need to actually structure how we're going to like set up these servers, right? Like which servers are going to do like which job or something, or like how are we going to actually respond multi-threaded to these questions that we know we're handling a lot of, right? And fundamentally what I see, right, when I see a problem of the kind that the original question kind of touched on, is people just like write down designs, but they've never actually figured out if those designs are the thing that will produce the actual performance that they want. And so it's much, much easier and it comes out much better if you let that design come out of a known efficient solution, because then you know that you have at least got a design that admits one performant solution. Then if you just make a design doc where the answer may be 0, it may be that you've made a design that admits no performance solutions, right? And so what I would say is like, design docs to me are like nearly worthless for that reason. It's because they really just can't be validated. And so to the extent that you would make them, I would think of them as more of a documentation of what I did after I did it, because I first need to go get the good solution or something sort of like it. And then the design doc that I make is not what I'm gonna do, it's what I did, so that now everyone can understand why. And I'll do this sometimes. I don't write design docs, but there are certain files in things I've written. They have a comment at the top. It's like 3 pages long. And it's just me going like, okay, so here are the things that this thing needed to do. And I tried a bunch of solutions. I document what I tried. I say, I tried doing this, but the locking was too expensive. What ended up happening was these 2 threads would constantly contend on this one thing. So I decided the most important thing would be to not have that lock in the system. That means that we can't do any of these things, but we can do these things. So I tried those, and this was the one that worked, right? The design doc, to the extent that it exists in my world, is always me documenting what worked, not me telling someone what I expect to have work. Because as far as I'm concerned, and I've been programming for 35 years, I still can't promise you that I can make any kind of a document, if I've never looked at a problem in detail like that, that will be anywhere close to optimal. I learn something on the way every time, still, to this day. That's the end of the question and answer session and the end of this entire video series. It has been a lot of videos in a very short period of time, and we would really like to extend a heartfelt thank you to everyone who tuned in and watched and went and backed our Kickstarter. It's been great, and we're very excited to send everyone our graphic novel series. So if you haven't had a chance to check it out, please do. It's just about over, and then we'll be getting to work getting books into everyone's hands, and we're really looking forward to that. That's it for the video series for a while. I will be taking a break from doing these because I did a lot of them in a short period of time. Obviously, Handmade Hero is always on weekly, where we just do programming education stuff every week. So if you want to keep on checking that out, I'll put the link to the Handmade Hero stream down in the link below as well. That's about it. Thanks everyone for tuning in, and until the next time we do a video series, have fun programming, and I'll see you on the internet. Take it easy, everybody.